Good morning friends, I welcome you all in this session. As you are aware, in previous session we were discussing about probability issues in networks and we have seen couple of very good examples. Let us move on to a different topic. In this topic we will be talking about different points like slacks, floats, what are these things and where do we apply these things, right? So as we have already seen, slack is something wherein you can delay a particular event for a particular duration without affecting the duration of the project. So maximum delay which is possible for an event without delaying the project is slack. As far as float is concerned, it is similar to slack, but we use in terms of for activities rather than for events, right? So floats for activities are same as slacks for events, right? So either you call it slack or you call float, meaning is same, but slack is for events and float is for activities, right? So how to define float? Float is again just similar to what we have defined in slack, right? So the amount by which you can delay an activity without delaying the duration of the project, so that is float. Basically there are 4 types of floats. In most of the books you will find 3 types of floats, but actually there are 4 types of floats. The first is total float. Total float is a float which has got the highest value amongst all these 4 types of floats. So the maximum delay possible for an activity without considering any delay in its precedence or succeeding activity. So the maximum time available for completion of an activity. So if you look at, let's say there are 3 activities, right? Let's say activity A, B and C. So B is the current activity, A is the preceding activity and C is the succeeding activity. So the maximum time available for delaying activity B is nothing but that would be called total float, right? Free float is the maximum delay possible for activities which will not affect the float of the successor activity. So you can delay an activity but without affecting the float of succeeding activity, right? Now you have got independent float. It is the maximum delay possible for an activity with used floats of preceding activity but will not affect the float of succeeding activity, right? So we have already used the float of preceding activity which will not and you are delaying a current activity without affecting the float of succeeding activity. And safety float. So safety float you can calculate when you finish the preceding job as late as possible and succeeding job is finishing as late as possible, right? So both the jobs, preceding and succeeding jobs are finishing as late as possible, right? So the difference between them minus duration of the activity. So we will calculate these floats. Keep in mind that always you will have total float value would be largest amongst these, then free float and then finally independent float, right? So we have considered only these 3, we are not looking at safety float, right? One more important characteristics is that only independent float can take negative value, right? The rest 2 floats are always either 0 or positive, right? So activities which are having all these floats 0 would be termed as critical activities. So this is another way of defining critical activity. What is critical activity? Critical activity is one which has got total float, free float and independent float 0, right? In other words, all the floats are 0 for critical activity. There are a couple of applications of these floats. As I said, the first application is that you can delay you can know which are the non-critical activities which can be delayed, right. So, it will give you what is to what up to what value you can delay a non-critical activity. It is important in crashing of network. In fact, we will be studying shortly what is crashing of network. It is nothing but the process of reducing duration of the project. So, we will take help of free float when we crash a particular project. And floats are also useful in resource allocation and resource smoothing, again because you can delay some of the activities in a project. So, you can delay because you want to, because you have got certain limited resources. So, it will help in resource allocation and smoothing also, right. So, let us look at an example. So, we can define float, we can define following for a given activity ij. So, actually there are in this network there are 3 activities hi, ij and jk. So, this thi is nothing but duration of activity hi, ij is tij is duration of activity ij, and tjk is nothing but duration of activity jk, right. Now, at all these nodes you can find out t and tls, right. So, let us look at focus on this particular activity which is in between these 2 activities, right. So, you have got TEI, earliest start of this particular at this particular node, then TLJ, latest completion time, then you have got earliest start time and latest completion time. So, these 4 time estimates you need to calculate at each node, right. So, if there are let us say 10 nodes in a network, you just calculate on all those 10 nodes these 4 time estimates. And I have already talked about what is TE. T is earliest start time, right. So, the earliest occurrence time for the event for which an activity arrow originates, right. So, once you know earliest start time, earliest finish time can be known just by adding the duration of activity. Similarly, latest finish time, as late as possible you can finish an activity, right, is latest finish time. So, latest start time can be calculated by subtracting the duration of activity from latest start time. So, these are very simple, right. So, you can easily calculate these time estimates. So, let us look at how to find out total float. Total float for activity ij is the difference between maximum time available and actual time that activity takes, right. So, maximum time available is TLJ minus TEI, right. So, you have got maximum time available. Let us say I have to go from Roorkee to Delhi and the maximum time available with me is let us say 8 hours, but actually the journey takes 5 hours. So, 7 minus 5 would be the total float, right. Free float. In fact, if you look at this particular table, in this table just look at, you have got succeeding activity and preceding activity, right. If you look at total float here, right. So, total float is here in this table. So, this equation you can formulate from this table. So, what is total float? The successor activity is finishing as late as possible and predecessor activity is starting is finishing as early as possible, right. So, the succeeding activity finishing as late as possible and preceding activity starting as early as possible minus duration of the activity, you will get total float. If you look at free float, it is based on the assumption that activities will happen at their earliest times. For example, all activities start as early as possible, right. So, it is the difference between earliest finish time and earliest start time. Like look at this free float, is the difference between earliest finish time and earliest start time of preceding activity. So, earliest finish time of succeeding activity, earliest finish time of preceding activity, right, very simple, minus duration of the activity, right. You should always subtract duration of the activity. So, this is total float and free float. Let us look at independent float. Independent float, let the preceding job or preceding activity finish as late as possible and succeeding activity start as early as possible, minus duration of the activity. Just see this, independent float is here. So, what is happening here? The preceding activity is finishing as late as possible, just see, preceding activity as late as possible, while succeeding activity is starting as early as possible, minus duration of the project, right. Safety float, let the preceding job finish at its latest possible and succeeding job finish as late as possible. So, this is safety float, right. So, both are succeeding activity is finishing succeeding activity finishing as late as possible and preceding activity is also finishing as late as possible, right. This is a very important slide, because in this slide one can calculate all these 4 floats: total float, free float, independent float and safety float. So, let us look at this network. So, what you have to do is, after calculating T's and TL's for the events, you just, if you want to calculate total float, then what you should do? TLJ minus TEI minus duration, right. You need not remember these formulae, right. So, you just look at the TL of this this event minus TE of this event minus duration, you are done. Free float, T of this, T of this, you have to look at only earliest start times, right. So, T of this minus T of this minus duration, you will get free float. If you look at independent float, T of this event and TL of this event minus duration of this activity, which is Tij, right. In all these cases, the duration of activity is Tij, and safety float TLJ minus TLI minus duration of the activity, right. So, this is very simple, and these are very simple equations, you can simply write down. Again, if you just focus on these 2 events, yes. So, event I, event J. So, let us take this is earliest start time and this is latest completion time. Similarly, earliest start and this end is latest completion, and the duration of the activity is Tij. So, what is total float? Total float, as I said, is the maximum time available. So, maximum time available is this minus duration of the activity, right. This is the equation which we have seen in earlier slides as well, right. So, maximum time available is for total float, right. So, look at this line, this point and this point is the maximum time available minus duration of the activity. Then free float would be smaller than total float, right. Tej of this minus Tei of this minus duration of the activity. third is TEJ of this event and TLI of this event, right, and minus duration of the activity, and safety float is this, right. So, this is how you can calculate all these floats, right. So, we will work out couple of examples how to find out floats, and we will focus on this particular slide, right. So, let me take up couple of questions and we will solve how to find out floats, because floats will help you in knowing which activities are critical activities, right. One, 2, 3, 4, 5 and 6. So, these are 6 events. There is one more activity here and there is a dummy activity. So, duration, this is activity A, its duration is 10, activity B, its duration is 8, activity C, its duration is 2, activity D, its duration is 8, activity E, its duration is 5, E5, G5, F9, and this is of course dummy activity, right. So, we will calculate all these floats. So, first of all you need to know TE and TLs for all these nodes, right. Okay. So, TE at this node is 0, TE at this node is 10, TE at this node is what? It is 12, right, 10 plus 2, 12. TE at this node would be, let us calculate at this node, it is 18, right. TE at this node would be, it is 17 from this side and 18 from here, right, T is 18. Then T at this node is what? It is 18 and 9, right, it is 27. So, T at this point is 27, right. Let us look at what are the values of TLs. TL is 27 at this node. Here 27 minus 9, TL is 27 minus 9. So, this is 1 and okay. So, 7, it's 18, right. TL at this point would be what? TL from here 27 minus 5 would be 22 and TL from here would be 18, right, because we have to take the least value, right. Now, TL at because we have to take the TL, we can okay, right, we have to take the from here to here, right. So, this is 22, right, and if you look at TL here is 18 minus 8, so this is 10, right. Then TL here it would be 17. Okay, TL here is 0, right. So, in this way you can calculate T and TL values, right. Now if you look at all these nodes, so at node 1, what is the slack is 0, right? At node 2 slack is 0. Node 3, what is slack? It's 5. At node 4 slack is 0, and node 5 slack is 0, right? So 1, 2, 4 and 5, 1, 2, 4 and 5, right? 1, 2, 4 and 5, this is your critical path, right? Now what about float? Let us, we have to calculate floats, right? So let us, at node 5, yeah, at node 5, yes, this is a positive value, right? So this is 4, right? And if you look at floats, so you have got total float, you have got free float, and you have got independent float. So we will calculate these floats for all these activities. So for activity A, B, C, D, E, F and G, right? So we will calculate this float. So let us calculate total float first. Total float for activity A. So we know that total float is TL minus TE, right? For activity A, TL minus TE. So 10 minus 0 minus duration of the activity. This is 0, right? TL minus TE, the total float for B. B is this, right? TL minus TE, 17 minus 0 minus 8. This is 9, right? C, TL minus TE, 17 minus 10, 17 minus 10 minus 2. So this is 5. D, what is D? TL minus T, 18 minus 10 minus duration 8, 0. For E, TL minus TE, right? This is activity E, right? So TL 22 minus 12 minus 5. So 17 and this 5, right? Now you have got F, activity F is here, right? So TL minus TE, 27 minus 18 minus 9, 0. For activity G, TL is this, TE is 18 minus duration is 5, this is 4. So this is how you should calculate total float for this network, right? And for all these activities. Let us calculate free float. What is free float? Just remember, free float is TEJ, TEI, right? You have to take only earliest times, right? So for A, TE and TE, so 10 minus 10 minus 10, sorry, 10 minus 0, 10 minus 0 minus 10, right? This is 0. So TE here, TE here. So 10 minus 0 minus duration of the activity. Now look at for activity B. Activity B is here, right? So TE minus TE of this, right? So 12 minus 0, 12 minus 0 minus 8, the duration of the activity, which is 4, right? For activity C, C is this, so TE minus this, right? So T is 12 here, T is 10 here, minus 2, this is 0. If you look at activity D is this one. The T here is 18, T is 10 minus 8, this is 0. So for activity E is this, right? T is 18 minus T is 12 here minus 5, right? So this is 1. Okay. Now if you look at activity F is here, right? So T is 27 minus 18 minus 9, 0. For G is this, right? 27 minus 18 minus 18 minus 5, this is 4. So this is how you can calculate free float, right? 0 4 0 0 1 0 4, right? Now let us calculate independent float. Independent float, if you look at this, is TEJ minus TLI, right? So T minus TL, right? So TEJ minus, for activity E, TE minus TL, right? So this is 10 minus 0 minus 10, this is 0, right? For B, T minus TL, right? So 12 minus 0, 0 minus 8, this is 4. For activity C, TE minus TL, right? So 12 minus 10 minus 2, this is 0. For activity D, TE minus TL, right? So this is 18 minus 10 minus 8, this is 0. For activity E, TE minus TL, right? So this is 18 minus 17 minus 5, so this is minus 4. For the first time we are getting any float value as negative, and this is minus 4, right? As I said that it is the only independent flow which can take negative value, right? For activity F, T minus TL is 27 minus 18 minus 9, this is 0. And finally G, you got T minus TL, 27 minus 22 minus 5, so this is also 0, right? So in this way you can calculate all the floats. Why did we calculate these floats? Let us look at for which activities you have got all these floats 0. So if you look at activity A, this is 0, this is 0, this is 0, right? For activity D, right? For activity D, this is 0, this is 0, this is 0, right? For activity F, this is 0, this is 0, and this is 0. So ADF is ADF are, these are critical activities and this is critical path. So we have just confirmed our findings of critical path using free float method. So this is how you can find out floats. Let us take one more example for finding these floats, but before this let me summarize what we have done today. In today's class we have looked at floats and slags. Slag is generally the delaying of an event without affecting duration of the project. Float is nothing but delaying of activity without affecting the project duration, and we have seen there are several applications. The first application is you can know which non-critical activities you can delay, right, because what happens when you delay a critical activity, you will also be delaying duration of the project, right. So, you can delay all these activities, right, which are non-critical. So, you can delay this activity by 9 minutes, 5 minutes, again 5 minutes and 4 minutes, right. There are other applications. You can use a free float method for crashing of project. We will see how to use free float method, and there are other applications like you can go for resource smoothing and resource leveling. And as far as types of floats are concerned, there are 4 types of floats. You have got total float, which is the largest float. This float is basically the maximum time available for doing an activity plus, minus the duration of the activity, right. So, this is the largest value. In free float, you consider that the preceding activity will start as early as possible, right, and the succeeding activity will also free float. If you look at this, is based on the possibility that all events occur at their earliest times. So, all activities start as early as possible. It is the difference between earliest finish time and earliest start time, right. This float would be somewhat less than total float. Just see here, in no case free float is more than total float. Similarly, in no case independent float is more than free float and total float. Just see, this is 9, so it has come down 4. It will they may be same, but it is not possible, it cannot happen that independent float and free float are more than total float, right. Similarly, independent float cannot be more than these 2 floats. However, they all may be equal, right, and the only independent float can take a negative value. So, we will take up one more question on finding out how to calculate total float, free float and independent float. So, with this let me stop here. In the next session we will be doing 2-3 things. After taking one more question on how to find these floats, we will move on to time and cost relationship, because that is another very important knowledge area of project management. So, with this let me complete this session here itself. Thank you very much.